Welcome, dear friend, to Dreamtime Science. Imagine yourself amidst shelves of ancient books, their spines worn soft under the gentle glow of a bedside lamp. The night outside stretches quietly, stars whispering old secrets through the window. Here, in this calm nook, we invite you to drift gently into stories wrapped in tranquility and wonder. If this moment feels right, a quiet tap of the like button or a soft word shared in the comments about where you listen from would mean the world. Let yourself settle now, adjust your pillow just so, breathe in slow, even rhythms. Together we will wander softly through the twilight realms of knowledge, letting curiosity soothe the mind while sleep tiptoes closer. Whenever you are ready, let your journey begin as we turn the page together. Tonight we'll glide very slowly, very gently into the quiet ripples of time, where moments fold and secrets whisper softly about journeys both forward and back. With a safe, pillow-soft distance, we'll cradle the curious dance of cause and effect, exploring the gentle mysteries of temporal tides and the grandfather paradox. Let your mind drift calmly as we unravel these delicate threads of time's quiet tapestry. Should these dreamy explorations accompany your journey to sleep, a gentle like or subscription would be deeply appreciated. What questions about our universe keep you wonderfully curious? Now take a moment, adjust your blanket, find the perfect hollow in your pillow, let your shoulders melt, breathe in and out. Close your eyes for a moment and let the world around you fade to gentle silence. In the shadows behind your eyelids, let imagination rise like the slow unfurling of a silk ribbon. Here in this twilight between waking and sleep, let us embark on a journey not through space, but through the very fabric of time itself. For as long as human beings have gazed up at the night sky, at the pinpricks of ancient starlight scattered across the black velvet of the cosmos, they have wondered, what is time? Can it be traversed, bent, unspooled, rewound? Is the past forever lost to us, or is it merely another country, waiting beyond a yet undiscovered border? The fascination with time travel is as old as storytelling itself. Before the churning machines of H.G. Wells, before the swirling blue police box of Doctor Who, before the shimmering portals and paradoxes of modern science fiction, there were already tales that toyed with time's arrow, myths and legends whispered of enchanted sleep and prophetic dreams, of gods who could step outside the river of days, who might grant mortals a glimpse of futures yet to come, or visions of epochs long vanished. In the Mahabharata, the ancient Indian epic, a king enters a forest and spends what seems like moments only to return and find centuries have passed. In Japanese folklore, the fisherman Urashima Taro visits an undersea palace and discovers, upon resurfacing, that the world he knew has faded into dust. The yearning to escape the steady march of seconds, to undo a mistake or relive a moment of joy, is written into the marrow of our bones. And so, from the fireside tales of old to the flickering screens of today, Stories of time travel have become a tapestry woven with threads of longing, regret, hope, and awe. To travel in time is to break the most fundamental of chains, the tyranny of causality, the relentless sequence of cause and effect, where every action leads inexorably to the next, and every moment is the child of the one before. Let us linger for a breath on this notion of causality. In the everyday world, it seems so obvious as to be invisible, like the air we breathe or the pull of gravity beneath our feet. You drop a pebble into a pond, and ripples spread outward in perfect circles. You strike a match, and flame blossoms at the tip. The present becomes the past, second by second, and the future rushes toward us, unseen. Yet if we imagine time as a tapestry woven by the ancient hand of Kronos, then causality is the rule that governs the pattern, ensuring that each thread follows logically from the last. But what if, in some shadowed corner of the loom, a thread could be plucked from its place and woven elsewhere? What if you could step outside the river of time, wander upstream or downstream, and act in ways that disturb the natural order of cause and effect? This is where science fiction, with all its wild audacity, leaps into the breach. It asks, what happens if a person journeys into the past and changes something small or something immense? Does the tapestry unravel? Is a new pattern woven, erasing the old one as though it had never been? Or do both patterns exist side by side in some dizzying superposition of realities? In the late 19th century, H.G. Wells ignited a new kind of wonder with his novella, The Time Machine. Here, for the first time, the traveller is not a mythic hero or a god, but an ordinary man in a world much like our own. Wells's protagonist, with his brass and ivory contraption, becomes the archetype of all time travellers to follow, bold, curious, and haunted by the consequences of his journey. The time traveller's machine whirs and hums, carrying him forward to the distant future, where he witnesses the rise and fall of civilizations, the slow dying of the sun, the ultimate entropy of all things. Yet in this story, as in so many that would follow, the lure of the past, the temptation to undo or revisit, is ever present. From Wells, the river of time travel fiction splits into 1,000 tributaries. In one, the traveller is a historian, passing through the centuries as a silent observer, like the ghostly protagonist in Ray Bradbury's A Sound of Thunder, whose accidental crushing of a butterfly in the distant past ripples forward to alter the course of history in unforeseen ways. In another, the traveller is a meddler, striving to change their own fate or the fate of the world, as in the frantic loops and reversals of films like Back to the Future, or the poignant longing of Audrey Niffenegger's The Time Traveller's Wife. The very act of imagining time travel invites us to probe the boundaries between fate and free will, memory and possibility, loss and redemption. It beckons us to ask, if you could return to a moment of crisis or joy, if you could warn your younger self or save a lost loved one, would you? Should you? And what might be the cost? Here, The concept of temporal causality, of cause preceding effect, of the past shaping the present, becomes a crucible for paradox. For in the world of time travel, the straight line of causation becomes a tangled knot. The most famous of these knots, glinting with philosophical mischief, is known as the grandfather paradox. Picture, if you will, a young inventor standing in the flickering light of his laboratory. Driven by grief and curiosity, he builds a machine that can carry him backwards through the years to a time before his own birth. His goal, for reasons both dark and compelling, is to find and prevent his grandfather from meeting his grandmother. If he succeeds, if his grandparents never meet, his parent will never be born, and if his parent is never born, then neither is he. But if he is never born, who was it that travelled back in time to prevent the meeting? The loop closes in on itself, like a snake devouring its own tail. There is no logical resolution, only a shimmering paradox, a challenge to the very foundation of causality. The grandfather paradox is more than a clever puzzle. It is a mirror held up to the laws that govern our universe. It asks whether the past is fixed, immutable, forever beyond our grasp, or whether it can be rewritten by the actions of a traveller from the future. It forces us to reckon with the possibility that time, rather than being a single, unbroken line, might branch and fork like the limbs of an ancient tree. In the realm of fiction, authors have proposed myriad solutions to this dilemma. Some imagine a universe in which any attempt to change the past is doomed to fail, the so-called self-consistency principle, where fate conspires to prevent paradoxes from arising. In such worlds, the inventor's gun jams, or his grandfather is saved at the last moment, or some unforeseen twist renders the attempted change impossible. Others conjure the multiverse, a branching cosmos in which each choice, each alteration spawns a new timeline, leaving the original untouched. Here the inventor might return to his own present and find it altered beyond recognition, while another world continues on as if nothing had changed. Still others revel in the paradox itself, allowing cause and effect to chase each other in endless circles. Time loops in which the origin of events is forever uncertain, as in the recursive predestination of Robert A. Heinlein's All You Zombies, where a single character becomes mother, father, and child to themselves, the ultimate Ouroboros of causality. Yet for all their variety, these stories are united by a common thread, the profound unease and the exhilarating freedom that comes with tampering in the domain of Chronos. Time in these tales is both a prison and a key, a force that binds us to our fates, and a door that, if only we could pry it open, might lead to redemption, revenge, or ruin. Why, then, are we so drawn to these tales, these thought experiments that twist reality into impossible shapes? Perhaps it is because at some level we are all time travellers, carried ceaselessly forward by the current of days. Our memories are shadowy portals to the past. Our hopes and fears are messengers from the future. The ache of nostalgia, the sting of regret, the trembling anticipation of what is to come. These are the hallmarks of creatures who dwell within time, yet dream of escaping its bounds. Science, too, has wrestled with the nature of time, though with tools more precise than the poet's pen or the dreamer's vision. The great physicist Albert Einstein, in his theory of relativity, dissolved the distinction between past, present, and future, merging them into a single four-dimensional continuum, space-time. In Einstein's universe, time is not an invisible river flowing from the past to the future, but a dimension woven into the very fabric of reality, as real and mutable as the distances between stars. Here, the speed at which time passes can be altered by motion or gravity, and the old certainties of simultaneity and sequence begin to blur. Yet even Einstein's equations, for all their grandeur, do not permit us to loop backward and rewrite our own histories. The arrow of time, the relentless increase of entropy, the transformation of order into disorder, of youth into age, of possibility into memory, remains unbroken. And so the paradoxes of time travel remain, tantalizing and unsolved, at the heart of our stories and our science alike. But let us linger a little longer in the realm of dreams, where paradox is not a barrier but a doorway. The grandfather paradox, with its looping logic, invites us to imagine a universe more strange and supple than our own, a universe in which the tapestry of time can be unpicked and rewoven, in which the rules of causality can be bent, if not broken. It is a place of infinite possibility, where each decision, each act of courage or cowardice might reverberate not only through the present and the future, but backward into the past as well. As you drift on the edge of sleep, feel the gentle tug of Kronos' tapestry stretching out around you. The stories we tell of time travel are more than escapist fantasy. They are a way of grappling with the deepest mysteries of existence, the nature of memory, the weight of regret, the hope for second chances. They are invitations to imagine what it might mean to live unbound by the arrow of time, to walk the labyrinth of causality with eyes open, to touch the fabric of reality and feel it yield just a little under your fingertips. And so the stage is set. The loom of Kronos stands before us, threads shimmering in the half-light, waiting to be traced and tugged. What lies beyond the paradoxes of story and dream? What does science, in all its rigor and wonder, have to say about the possibility of travel through time's endless corridors? The journey continues, the tapestry unspools, and the night stretches on, rich with promise and mystery, as we prepare to follow the thread deeper still. Let us return, then, to the silent corridors of time, where every second seems to echo onward, pulling the present into the future, while trailing the past in its wake. If the first glance at time reveals a tapestry, woven with threads of before and after, then a second, more searching look uncovers knots and tangles, places where cause and effect twist and loop back upon themselves in ways that tease the limits of our logic and our language. Tonight, our lantern will illuminate those tangled places, the intricate maze of temporal causality. Causality, that ancient companion of time, is the notion that every effect has a cause, and that causes precede their effects. This seems, on its surface, so simple, so foundational to our understanding of the world, that to question it feels almost like doubting the firmness of the ground beneath our feet. Drop a stone in a pond, and you expect the ripples to emerge after the splash, not before. Strike a match, and only then does it flare into light. Yet as we peer deeper, we find that the folds of reality are not always so obedient, and causality itself is a thread that sometimes frays or even loops back to touch itself. Begin for a moment with the classical world, the world of Newton and his clockwork universe. In this realm, the equations that govern the motion of planets and the fall of apples are, in a word, reversible. If you were to watch a film of billiard balls colliding and then run it backward, the collisions would still make sense. The mathematics allows for time to flow in either direction. And yet our lived experience is that time has a direction, an arrow, pointing inexorably from yesterday to tomorrow. The laws of mechanics do not tell us why a cup shatters when it falls, but never leaps back together of its own accord. They are silent on the question of why we remember the past, but not the future. To find a clue, we must look to another of nature's laws, the second law of thermodynamics, that stern arbiter of disorder. It tells us that in a closed system, entropy, the measure of disorder, tends to increase. The universe drifts from order to chaos, from the crystalline to the diffuse. Here at last is a hint of asymmetry, a reason why eggs break but do not unbreak, why stars burn out but do not reignite from their ashes. Entropy provides time with its arrow, whispering that causes must precede effects, for to do otherwise would be to turn back the cosmic tide of disorder. And yet, even this explanation is not as watertight as it might seem. Entropy, after all, is a statistical law, one that speaks in probabilities and averages, not certainties. Given enough time and enough particles, the odds against a broken cup reassembling itself are so astronomical as to be, for all practical purposes, impossible. But in principle, the equations do not forbid it. The arrow of time, then, is a matter of overwhelming likelihood rather than absolute decree. Let us step now into the quantum world, where causality seems, at times, to tremble on its axis. In this domain, the dance of particles is governed by probabilities and uncertainties, by wave functions that spread and interfere. Here, causes and effects blur, and events do not always unfold in neat, sequential order. Consider the phenomenon of quantum entanglement. Two particles, once linked, can share properties instantaneously, no matter how far apart they are, a whisper across the void, faster than light. Change the state of one, and the other responds, as if by prearranged agreement. To the untrained eye, it may seem as though information is leaping backward through time, effect preceding cause. Yet, on closer inspection, we find that no usable information travels faster than light, and so causality, bruised but not broken, staggers on. Still, the quantum world offers deeper puzzles. Take, for instance, the delayed choice experiments, where a particle seems to decide its past based on a measurement made in the future. Fire a photon at a beam splitter, and whether it behaves as a particle or a wave depends on how you choose to measure it after it has already passed through the apparatus. It is as if the act of observation reaches backward in time, determining not just the outcome, but the very nature of the photon's journey. Does this mean the future is rewriting the past? The mathematics allows for such retrocausality, but our intuition rebels. The boundaries of temporal causality are tested further still when we contemplate the possibility of time travel, those fantastical loops in the fabric of time that haunt both science fiction and the outermost edges of physics. The equations of Einstein's general relativity, so precise in their description of gravity and the curvature of space-time, admit solutions that resemble tunnels through time, closed time-like curves, where one could, in theory, revisit yesterday's dawn or tomorrow's twilight. The most famous of these is the Gödel metric, a solution in which the entire universe rotates, allowing a traveler to loop back to their own past. More familiar, perhaps, are the so-called wormholes, bridges between distant points in space-time that, if traversable, could connect not just locations, but epochs. But these dreams are haunted by paradox. If one could travel back and alter the past, what becomes of causality? The classic grandfather paradox asks, what if you journeyed to a time before your birth and prevented your grandparents from meeting? Would you vanish from existence, or would the universe somehow defend its own consistency? Some physicists propose that the laws of probability conspire to prevent contradictions, that any attempt to change the past would inevitably fail, the universe gently nudging events back onto a self-consistent path. Others suggest a branching of realities, with each choice birthing a new timeline, a forest of possibilities growing ever denser with every act of retrocausal interference. Yet even in the absence of time machines, we find subtler forms of causal ambiguity. In the tangled equations of quantum mechanics, there are processes that seem to defy a clear-cut ordering of events. Consider the case of so-called quantum switches, where the sequence in which two operations are applied to a particle is not set in advance, but is itself a quantum variable. Both orders exist in superposition until measured. In such scenarios, the very notion of before and after becomes fuzzy, a shimmering haze rather than a sharp line. The logical boundaries of causality are further tested by the notion of information flow. In our everyday world, information travels at finite speeds, bound by the speed of light. No message, however urgent, can outrun this cosmic speed limit. This principle, known as causality or locality is woven into the very fabric of relativity. But quantum mechanics, with its entanglements and non-local correlations, teases the possibility of influence without mediation, a universe where information seems to leap across space and perhaps time itself. The so-called no-signaling principle preserves causality by ensuring that these quantum correlations cannot be used to send messages faster than light, but the tension between quantum theory and relativity remains one of the deepest mysteries in physics. Let us pause now to consider the philosophical dimension of causality. For millennia, thinkers have pondered whether causality is an objective feature of the universe or merely a convenient framework imposed by our minds. David Hume, the Scottish philosopher, famously argued that causation is not something we observe directly, but rather a habit of thought, a pattern we impose upon the regularities of nature. When we see one event follow another, we infer a connection, but the necessity of that connection is a product of expectation, not observation. In the quantum world, where probabilities reign and events can be correlated without local causes, Hume's skepticism finds new resonance, and yet causality remains indispensable to science. It is the scaffold on which we build our models, the backbone of explanation and prediction. To abandon it would be to drift unmoored in a sea of events, unable to navigate from question to understanding. But as we probe the frontiers of knowledge, we must be willing to entertain the possibility that causality, too, is a local phenomenon, emerging from deeper laws that may not resemble our everyday intuitions. The logical boundaries of causality can be glimpsed most clearly in the realm of paradox. The grandfather paradox is but one example. There are many others, each a knot in the thread of time. The bootstrap paradox, for instance, asks what happens when an object or piece of information is passed from the future to the past, becoming the very cause of its own existence. Imagine a time traveller who hands Shakespeare a copy of Hamlet, which Shakespeare then copies out and claims as his own, only for that same manuscript to be delivered to him centuries later. Who then is the true author? The circle is complete, but causality is left dangling, with no clear origin point. Such paradoxes force us to confront the possibility that our usual notions of cause and effect may be incomplete or even fundamentally flawed. Some physicists have speculated that the universe itself may be a self-consistent loop, with every event, both cause and effect, the serpent forever swallowing its own tail. Others argue that causality is an emergent property, a pattern that arises from the statistical behavior of large numbers of particles, but which dissolves at the quantum scale. In the gentle quiet of the night, as your thoughts drift among these tangled threads, you may wonder what all this means for our understanding of reality. If causality is not absolute, if time can bend and twist, if effects can precede their causes in some strange, deep logic, then what becomes of free will, of memory, of the very notion of history? Are we the authors of our own stories, or merely actors reciting lines written long before we took the stage? Physics, for all its rigor, cannot yet answer these questions. The boundaries of temporal causality are, for now, the boundaries of our knowledge, a horizon shimmering with possibility and paradox. The equations allow for strange loops, for time machines, for worlds where cause and effect are as malleable as dreams. But whether these possibilities are realized in our universe, or whether they remain forever confined to the pages of theory and fiction, is a question that awaits the patient unfolding of discovery. As the night deepens and the stars wheel overhead, one might sense the gentle pull of curiosity tugging ever onward. The complexities of temporal causality have not diminished the wonder of time, but only enriched its mystery. Each paradox, each puzzle is a signpost pointing to deeper truths, to realms where our present understanding falters and the unknown begins. Somewhere in the darkness, a clock ticks, indifferent to the puzzles we pose. Its hands trace circles, marking the passage of moments that can never be reclaimed. Yet even as the present slips into the past, new questions arise, beckoning us onward to the next turn in the labyrinth, where the fabric of time may reveal yet subtler patterns, yet deeper complexities. There on the far horizon lies the promise of new insights and the gentle, unending pull of wonder. Across the centuries, the human mind has yearned to step beyond the iron rails of time, to glimpse what lies ahead, or reach back and touch the vanished world of yesterday. Yet, as the dream of time travel has swirled through our mythologies and fictions, earnest minds, philosophers, physicists, mathematicians, have turned to the workbench of reason and the forge of mathematics, seeking to probe the possibility with the tools of their trade. Tonight, in the quiet hours, we will walk the gallery of those tools and techniques, tracing the shadowy borderlands where science and speculation meet, and where the investigation of time travel has taken on its most rigorous forms. Long before quantum equations or space-time diagrams, the first instruments wielded in the study of time were not devices of brass and glass, but language and logic. The earliest recorded musings on temporal paradoxes came from the ancient Greeks, whose paradoxes of motion and continuity would echo down the halls of inquiry for millennia. Zeno of Elea, with his famously perplexing paradoxes, did not speak directly of time travel, but his puzzles about the divisibility of time and space planted seeds that would bloom much later. In pondering how Achilles might never overtake a tortoise in a foot race, Zeno revealed the subtle intricacies of time's passage and the challenge of describing change itself, a philosophical foundation upon which future explorers of temporal manipulation would build. As the centuries passed, the tools grew sharper. The medieval scholastics, keen to reconcile faith and reason, debated whether God's omnipotence could allow for the rewriting of history, or whether the past, once written, was fixed for all eternity. Here the first glimmers of the grandfather paradox flickered into being, centuries before it would be named. Could a being, divine or otherwise, undo the events that led to its own existence? The debate danced through theology and metaphysics, sharpening the questions that time travel would pose. But it was in the age of science, when Galileo, Newton and their successors began to quantify motion and the fabric of reality, that the study of time leapt from philosophy into the domain of physical law. Newton's universe was one of absolute time, ticking evenly and relentlessly across the cosmos, much like a vast, unseen clock. In such a universe, the notion of travelling through time in any direction but forward seemed as fanciful as flying to the moon on a chariot of fire. Yet this very rigidity would one day provoke new generations to challenge its assumptions, to ask, what if time were not absolute? To investigate such questions, scientists needed new tools. Tools that could capture, if only in the mind's eye, the strange and flexible nature of time suggested by relativity. Enter the thought experiment, a device of pure imagination, honed by logic and mathematics, capable of exploring worlds unbuildable in the laboratory. It is here, in the realm of the thought experiment, that time travel has been most thoroughly explored, its paradoxes and possibilities laid bare as if upon an operating table. One of the earliest and most enduring of these mental instruments was the idea of the block universe, a concept born from the work of Hermann Minkowski, who in the early 20th century recast Einstein's special relativity in terms of four-dimensional space-time. In this vision, all of history, from the first flash of the Big Bang to the last dying embers of the cosmos, exists together in a vast static structure. Past, present, and future are not moving points along a line, but rather parts of a whole, equally real and eternally fixed. This framework gave rise to the question, if all moments exist, could consciousness itself slip from one to another, as a needle jumps, grooves on a record? The tools to analyze such a world were mathematical, yet their conclusions were philosophical. In the block universe, time travel is, in some sense, simply a change of perspective, a movement through the grand tapestry rather than along a narrow thread. But such a model also raises thorny questions. If the future exists as surely as the past, are we truly free to choose, or is every action predestined? The block universe does not, on its own, offer a means of travelling through time, but it provides a scaffold for deeper inquiry, a way to imagine the landscape in which such journeys might occur. As the 20th century unfolded, the most celebrated and fruitful tool for probing time's mysteries emerged: Einstein's general theory of relativity. In this new vision, space and time were not rigid backdrops, but malleable, interwoven fabrics, capable of being stretched, twisted, and curved by matter and energy. In the equations of general relativity, the possibility of closed time-like curves, paths through space-time that loop back upon themselves, arose not as fantasy, but as a mathematical consequence of the theory's structure. Here at last was a foothold for the scientific investigation of time travel. But how to probe such possibilities when the laboratory was the universe itself and the equipment required was the mass of a star or the energy of a galaxy? Once again, the thought experiment became the tool of choice. One of the most famous was Kurt Gödel's solution to Einstein's equations, which described a rotating universe, a cosmic whirlpool in which the geometry of space-time bent back upon itself, allowing for closed time-like curves. In Gödel's universe, it would be possible, in principle, to set out on a journey and return to one's own past. Yet this solution bore little resemblance to our own cosmos, which does not appear to rotate in such a fashion. Still, the mere existence of the solution showed that the laws of physics, as written by Einstein, did not outright forbid time travel. The mathematical toolkit expanded further with the study of wormholes, hypothetical tunnels through the fabric of space-time, first popularized by Einstein and Nathan Rosen in the 1930s and later refined by theorists such as John Archibald Wheeler and Kip Thorne. The Einstein-Rosen bridge, as it was first known, was a solution to the equations of general relativity that connected two distant points in space-time via a shortcut, a sort of cosmic subway that might in principle allow for rapid transit between regions otherwise separated by vast gulfs of space and time. But could such a bridge be traversed by a traveller, and could it be manipulated to permit journeys not just through space, but through time? In the 1980s, Thorne and his colleagues advanced the study of traversable wormholes, exploring the energy requirements and the physical plausibility of such structures. They discovered that in theory, a wormhole might be converted into a time machine if one mouth were accelerated to near the speed of light and then returned to its original position, a process that, thanks to the time dilation effects of special relativity, would leave the two ends of the wormhole desynchronized in time. Step through the wormhole and you could emerge in the past, relative to your point of origin. This scenario, while mathematically consistent, posed daunting challenges. The construction of a stable, traversable wormhole would require exotic matter, a form of material with negative energy density never observed in the natural world. The mathematics permitted it. The universe, so far as we can tell, does not. And yet, the careful exploration of the equations and the relentless search for loopholes and constraints became the principal tools of inquiry. Here, theory and imagination worked hand in hand, each pushing the other to new realms of possibility. But theory alone was not enough. The investigation of time travel demanded not just the construction of hypothetical worlds, but the testing of those worlds for consistency. Here, the philosophical tool of the paradox took center stage. The grandfather paradox, an old riddle in new clothing, became the touchstone for such inquiries. If a traveller journeyed to the past and prevented their own grandfather from meeting their grandmother, would they cease to exist? And if so, who then undertook the journey? Physicists and philosophers devised clever responses. One was the Novikov self-consistency principle, named for the Russian physicist Igor Novikov, who argued that the laws of physics would conspire to prevent paradoxical events. In this view, any action taken by a time traveller in the past would, by necessity, be part of history all along. The universe, it seemed, might be more like a finely tuned machine in which all events fit together seamlessly than a mutable canvas upon which any future could be painted. To probe this principle, theorists turned once again to the thought experiment, crafting ever more intricate scenarios. Consider the case of the information paradox, where a time traveler brings back a piece of knowledge, a theorem, say, or the plans for a device, that is never actually discovered, but simply passed in a loop from future to past and back again. Who then is the author of the information? Does it have an origin at all, or is it a kind of ontological oddity, a thing without a creator? Such questions stretch the tools of logic and causality to their breaking point, and yet, in wrestling with them, scientists have deepened their understanding of the constraints imposed by the laws of nature. Quantum mechanics, too, has entered the fray, its own peculiar tools and techniques casting new light on the shadows of time. The quantum world is one of probabilities and uncertainties, of superpositions and entanglement, a realm where cause and effect are not always so neatly demarcated. In the late 20th century, physicists began to ask whether the strangeness of quantum mechanics might permit or forbid time travel in ways that classical physics could not. One line of inquiry involved the study of quantum closed time-like curves, hypothetical situations in which quantum information could loop back on itself. Here, the thought experiment again proved indispensable. What would happen if a quantum particle interacted with its own past self? Would paradoxes arise, or would the probabilistic nature of quantum mechanics smooth away the contradictions? Some models suggested that the universe would enforce consistency by allowing only those histories that were self-consistent, a quantum echo of Novikov's principle. Others hinted at the possibility that information could be erased or altered in subtle ways, preventing paradoxes from arising. Experimental tools, too, began to play a role, albeit in miniature. Quantum optics laboratories have devised clever analogues for time travel, using entangled photons and delay lines to mimic the behavior of information traveling backward in time. These experiments do not send matter or consciousness through the ages, but they do illuminate the boundaries of what is possible and the ways in which information and causality are intertwined. Yet, for all the sophistication of these tools, mathematical models, thought experiments, quantum laboratories, the investigation of time travel remains at its core an exploration of the limits of our knowledge. Each new technique reveals both new vistas and new puzzles, sharpening the questions even as it deepens the mystery. The study of time travel, perhaps more than any other scientific pursuit, reminds us that our tools are not just extensions of our hands, but of our imaginations and our doubts. As the night deepens and the stars wheel overhead, one might sense the quiet hum of unending inquiry, the endless refinement of tools and ideas. We have peered through the looking glass and glimpsed the strange realms that lie beyond, but the journey is far from over. For even as we trace the contours of paradox and possibility, there remain other horizons to seek, places where the arrow of time, that most familiar of companions, may fracture, bend, or dissolve entirely. And so, with our instruments of mind and mathematics in hand, we drift onward into the unexplored lands that lie ahead, where the nature of time itself awaits further unraveling. There is a hush that settles when one pauses at the edge of the known, a hush laced with both anticipation and humility. In the realm of time travel, this hush is ever present, a gentle reminder that the boundary between science and philosophy is a porous, shifting shore. As the night deepens and thoughts drift like leaves on a slow-moving river, we find ourselves listening, not just to the tick of clocks or the measured pace of pulse and breath, but to the subtle, persistent echo of questions that have haunted humanity since we first learned to count the days and mark the seasons. To contemplate time travel is to stand before a mirror that distorts and reflects, that multiplies images and possibilities, until the familiar shape of our lives is cast into new and startling relief. It is to become aware, keenly, sometimes uncomfortably, of how entangled we are with time, how it shapes our sense of self, of story, and of meaning. The idea of moving through time, of stepping outside its river to look upstream or down, awakens a yearning that is not merely scientific curiosity, but something deeper, a longing to touch the past, to glimpse the future, to understand the web of cause and consequence that binds us to every moment that has been and every moment yet to come. In the quiet dark, it is easy to imagine the philosopher's study, lit by the dim glow of a lamp, a clock ticking somewhere out of sight. Here, time travel slips free from equations and models and becomes instead a question about the very nature of reality. Is the past gone, or does it persist, waiting for an intrepid traveller to return? Is the future already written, its events as fixed and immovable as mountains, or does it flow from a wellspring of possibility, shaped by choice and chance? These are questions that science, with its insistence on experiment and evidence, can only partially address. The rest is the province of thought, of speculation, of wonder. Consider the paradoxes that have become almost folkloric in their familiarity. The grandfather paradox, for instance, in which a traveller's journey to the past might undo their very reason for being. Or the looping scribe, who leaves a message for their younger self, and so becomes both the origin and the recipient of an idea that seems to have no true source. These are not merely puzzles for the intellect. They are invitations to consider the fragility and contingency of existence, the delicate balance between agency and fate. To ponder them is to brush against the limits of logic, to sense the outlines of mysteries that may never be resolved. At the heart of these questions lies a deeper unease and awe, the recognition that time is not merely something we move through like fish in water, but something that shapes and confines us, that weaves together memory and hope, regret and anticipation. Our experience of time is so intimate, so immediate, that to question its flow is to question the very texture of reality. What if, for a moment, we could step outside that flow? What would it mean for our sense of responsibility, for our understanding of self, for the way we love and grieve and strive? Philosophers have long wrestled with these themes. Augustine, centuries ago, mused on the elusive nature of time, noting how the past is gone, the future is not yet, and the present slips from our grasp even as we try to hold it. The arrow of time, so clear in our daily lives, becomes blurred and uncertain under the probing light of reflection. Later, thinkers like Henri Bergson would distinguish between time as measured by clocks, objective, external, indifferent, and time as it is lived, the durée of consciousness, flowing and elastic, shaped by memory and desire. Here, perhaps, is one of the most profound implications of time travel's allure. It reveals to us the strangeness of our own experience, the ways in which we are already travelers in a dimension we can never quite master. Our memories, after all, are a kind of time machine, allowing us to revisit moments long past, to taste again joys and sorrows, to rehearse old arguments, to reconstruct lost loves. Our dreams and fears project us into possible futures, imagining triumphs or disasters, rehearsing for realities that may never unfold. If time travel were possible, if we could truly walk the corridors of history or leap ahead to worlds unborn, would we be the same? Would we recognize ourselves scattered across the landscape of possibility? Or would the very act of stepping outside the present unravel the threads that hold us together? To travel in time is to risk becoming unmoored, to float free from the anchors of memory and identity that give shape to our days. There is, too, a moral dimension to these imaginings. The temptation to change the past, to undo mistakes, to rescue the lost, to avert catastrophe is powerful. But with it comes the recognition that every act, however small, sends ripples through the fabric of events, consequences multiplying in unpredictable ways. Would we, given the chance, dare to meddle? Or would we find, as so many stories suggest, that the past resists change, that the threads of fate are more tightly woven than we suppose? Here, the fantasy of control collides with the humility of acceptance. Perhaps some things are meant to be, or perhaps more unsettle. Ingly, there is no meaning but what we give. Yet even as time travel tantalizes with the promise of mastery, it confronts us with our limits. The unidirectional flow of time, the irreversibility of certain events, the finality of loss, these are not merely obstacles to overcome, but reminders of what it means to be human. For in our inability to return, to redo, to reclaim, we find the poignancy of life, the preciousness of each unrepeatable moment. The fantasy of time travel, in this sense, is a mirror for our yearning, but also for our wisdom. To accept what is, to cherish what was, to hope for what may yet be. The arts have long served as a laboratory for these philosophical explorations, giving voice to our doubts and desires in stories that circle and return, that fold time upon itself in 1,000 imaginative ways. In the poet's verse, the painter's brush, the filmmaker's montage, we see time stretched and compressed, reversed and replayed. These works invite us to dwell for a while in worlds where the past can be revisited, the future glimpsed, the present expanded into infinity. They remind us that even if the laws of physics hold us fast, the imagination is unbounded, able to leap across chasms of years in an instant. There is a strange comfort in this, a recognition that the human connection to time travel is not rooted solely in the hope for technological triumph, but in the deeper, older magic of narrative. We are, at our core, storytelling creatures, weaving the disparate events of our lives into a tapestry of meaning. Each memory recalled, each plan made, is a small act of time travel, a bending of the now to encompass what was and what might be. In this sense, time travel is less a destination than a metaphor, a way of grappling with the mystery of existence. Even in the most rigorous scientific circles, the allure of the unresolvable persists. Theoretical physicists debate whether the universe is deterministic, whether the future is as fixed as the past, or whether uncertainty and chance are woven into the fabric of reality. Quantum mechanics, with its superpositions and entanglements, suggests a world where possibility reigns, where the act of observation collapses the multitudes into one lived outcome. Here too the boundaries blur. Are we, by choosing, shaping the future, or are we simply discovering what was already written? In recent decades, the idea of the multiverse has added new layers to these philosophical puzzles. If every choice spawns a new branch of reality, if every possibility is actualized somewhere, then what does it mean to travel in time? Are we traversing a single thread, or leaping between worlds, each as real as the last? The prospect is dizzying, exhilarating, and ultimately humbling, a reminder that our understanding, for all its sophistication, remains partial, provisional, a work forever in progress. This sense of humility, of wonder before the unknown, is perhaps the most enduring gift of the time travel question. For all our striving, for all our attempts to measure and model and master, there remain mysteries that elude us, that beckon us onward. The arrow of time, the nature of causality, the boundaries of memory and possibility. These are not merely puzzles to be solved, but invitations to contemplate, to linger in the presence of what is bigger than ourselves. And so, as night deepens and the world quiets, we are left with the echo of the question, what is it truly to be a traveller in time? Is it to possess a machine, a device that whirls and clicks, transporting us bodily from one era to another? Or is it, more simply and more profoundly, to be alive, to remember, to anticipate, to dream, to regret? Perhaps the deepest time travel is the act of living itself, moving inexorably forward, carrying within us the shadows and lights of all we have been and all we hope to become. The ancients, gazing at the stars, marked the passage of hours and seasons, built monuments to the solstices and the equinoxes, inscribed their stories in stone and song. They knew, as we do, the ache of loss and the thrill of possibility, the poignancy of moments that slip forever out of reach. Their myths and legends are filled with travelers, heroes who journey to the underworld, who return changed, bearing wisdom or sorrow. In these tales, as in our own, time is both a river and a labyrinth, a force to be reckoned with and a mystery to be embraced. As the mind drifts, lulled by the rhythm of breath and the soft pulse of the heart, there is a sense of kinship, a recognition that to wonder about time is to participate in a very old conversation. The philosophers and physicists, the poets and dreamers, all gather in this quiet space, their voices mingling, their questions echoing through the corridors of thought. Time travel, in the end, may be forever out of reach, or it may be closer than we think, woven into the very fabric of our being. There is no final answer, no tidy resolution. The mystery remains, shimmering at the edge of thought, inviting us to return, to ask again, to wonder anew. As the stars wheel overhead and the night deepens, the question persists, a gentle, insistent echo, calling us onward through the ever-unfolding present, toward whatever futures may await. As our journey through the swirling currents of time gently drifts to a close, we watch the comet tail of causality fade softly into the hush of space. May these whispers of paradox and possibility lull your thoughts into peaceful wonder, inviting you back to dream alongside more cosmic mysteries in our next quiet voyage.